Hello, I'm Matt Hoots with Rata Green. This video is part of a series. The rest of the videos with titles and links to the other videos are in the description below.
All right, so let's now we'll get into some of these projects and some of what we've learned, mistakes we've made, and how we are where we are today. The first one is a project I mentioned already, the tiny house. We did actually do a combination of cavity and exterior on this one. This is in Central Florida, about an hour north of Tampa, and it's about 600 square feet with the loft, but the footprint is about 400. So it's more of a cottage than a tiny house, but it's still low volume. And so when you see this number 0.2 ACH 50 on a volume this small, that's a lot. That's easier to achieve on a much larger home, because again, this is based on cubic feet of the home. So again, 2 inches of exterior over zip system sheeting. We got our zips. We spent a lot of time on this layer right here to get every crack, gap, and hole and penetration sealed up perfectly. This is a stone wool bat insulation in the walls, and then 2 inches on the exterior, a 1x4 furring strip for our rain screen, and then a metal, that's a standing seam metal cladding there, and then the roof is the same standing seam metal. And here's a shot of the exterior. This is the furring strip here. All of it's horizontal because we needed to do that for the standing seam. And the airflow happens, there is a gap. The standing seam actually bows out just slightly. So there is a gap that allows the airflow past the furring strips. This floor is something we were experimenting with because it was our own home. We could do this. I'll show you some pictures of how we did this, but you can see that it's the exact same assembly as the walls, just turned 90 degrees. And so we filled cavities here with insulation on the bottom side, and so everything is all at the exterior. This is the hygrothermic analysis of this of the assemblies here, and this shows you where our the sheeting temperature here drops about 50% between the drywall and the sheeting. The temperature drops to the sheeting, and then we drop even further. 42 degrees is the design temperature there, the coldest about 1% of the year. And so that's what this looks like. We're again looking at all these factors in deciding what assembly works best. And so we dip a little bit above our threshold here, but we're not at risk. This is a very short period of time, and because the assembly can dry out, because the insulation is very vapor open, we're and very has a high drying potential. We're not concerned about this. This shows without the exterior that our sheeting temperature would be closer to the exterior, so we may experience some condensation there. So this is like I said, it's an experiment. We built the floor upside down so that we could have that continuity in the sheeting. Otherwise, this is a stem wall here. And so because instead of putting the framing right on top of the sill plate here and then butting the sheeting up to the sill plate, the house right here, you can see a cantilever and this happens on both ends of the home and on the front and on the back, And so we have that, you can see there, the sheeting just continues sitting on top of the framing. So it's not interrupted. We're not having to deal with that intersection of the beam meeting the sheeting. And so we flip this thing using, just pulling this thing slowly, one section at a time. Again, this is very tedious, and we've come up with other ways to handle this, but this worked really well because it was a small house. Certainly wouldn't recommend it on a large one unless you had a crane. But this is, again, trying to get that continuity. And so it was fun. It was labor of love, but it worked out. We did, deep 2x12 flooring just so we could get plenty of insulation and still have room for all of our utilities without having to interrupt the insulation much. And then our, little details like this is where it happens. This is where it matters. This is a hurricane clip. This is the zip system on the bottom of the floor structure, and this is going down to the sill plate. And then we just dress that with a lot of zip system sheeting. There are liquid flashing to seal up that penetration, and that happened at every single one of them. So it's a little tedious, but again, that's where it pays off, is paying attention to every little detail like that. This showing the insulation on the bottom of the floor on the exterior, and then here we are with the insulation in the cavities of the floor, turning that insulation up here at the edges so that it's connected to, when you build the wall on top of it, it does continue, so your thermal control layer continues. This is the floor meeting the wall, the insulation overhangs down below, and then we'll install the exterior below. This is showing that all of our air and vapor control layers here with the zip system sheeting. This was the start of, you can see every nail is covered with the liquid flash. Yes, it can be tedious. It's not necessarily required. Manufacturer doesn't require that. We did end up doing it on the roof because we didn't, with all the rain that we had down there, this is our preferred method to treat the roof, just attacking every possible leak for air or water. And again, horizontal furring strips, this is the whole thing wrapped in the insulation now. We're ready for cladding. This structure here is built separately. It's not actually attached to the structure. So the ledger board is on the outside of the insulation. And we do all of our decks and roofs like this. Okay. This is showing, the wall before we insulated the roof. Just some more details here. Again, continuity of insulation, and getting ready we got this part up here. This is just structural strapping here, and that goes on before the insulation. So that again stays within the control layers there. This is in North Carolina. This one's got down to 0.5 ACH50, and this is an image from an article we did in JLC, the Journal of Light Construction, where we're showing here the zip system running on top of our ceiling joist. These are 2x10s, and then we filled up on top of that. We created this platform, which made it easy for the framers they had something to stand on here when they were stick building a roof. And so this whole area here is just filled up with R60 insulation, and we did 2 layers of like a bat, and then we did like a loose fill stone wool insulation on top of that. And so this right here, this detail right here made it possible to be as tight as we were, but then we had this continuity. Their energy bills are the highest they've seen, and it's a 3,500 square foot home. The highest they've seen is about $100. The average is around 50. And they're conservative, and so they probably keep the temperature not extreme, but they don't crank it. But they one time tried to use their wood burning or the gas stove or gas fireplace that I told them they didn't need. They used it, and within 10 minutes they had to turn it off because it was just too hot. It's just the house contains that heat really well. These are the hygrothermic analyses for this home, just trying different assemblies. And you can see here listing the different assemblies we tried. 5.5 inches in the walls, because this is a 2x6 that you can see up here. We only use 3.5 inches of insulation. This gives us room for electrical, a lot of plumbing, or a lot of the utilities can happen in this part of the cavity. So it makes it a little more flexible, a little easier to work with here. And then So we explored different options there, 2 inches on the outside, 3 inches, and then different varieties of cavity. And so we ended up with the 2x6 wall, 3.5 inch bats, and 3 inches exterior. And here shows with this combination our sheathing temperature between 18 and 60. And this is again North Carolina, up in the mountains. If we hadn't done exterior, our sheathing temperature would be closer to 18 on the design temperature. And here again, this is the roof or the deck structure isolated from the home. It's a standalone. We do have a bolt, a couple of attachments through this column into the structure here. Very minimal thermal bridging with those attachments, and we of course sealed it extremely well as it penetrated. So it's very trivial, the amount of penetration, but at least for the most part, we don't have a continuous thermal bridge with the ledger. And that's how we've designed and worked around that. And then this is the front porch. It's a front stoop, so it's a concrete stoop here, and you can see we put 2 inches in between it and the wall. Actually, that's 3 inches to prevent that thermal bridge. Concrete, metal, the most conductive materials that we build with. So it's really important that we keep concrete away from our structure to prevent that thermal bridging. This was our electrician's favorite job ever. They had zero, when they're doing a ceiling, they didn't have to work. These aren't IC rated. They're not, we're able to just install and not worry about the insulation that's going to go, not have to, it was so easy for them to install everything from electrical to any plumbing that would run through. So it worked out really well. They loved it. This is the off-grid homestead that we did in Western North Carolina. There were 4 buildings. This one in the image here is a barn. All of them no more than 0.5 ACH50, this climate zone 4. This one has the most we've ever used in terms of exterior insulation, 6 inches on the walls and 8 inches on the roof. All of the framing is heavy, 18 gauge, it says 20, but it's 18 gauge panelized framing. And that was, all of this is being off grid, and they're mild preppers. They actually wanted this to be there. They wanted to be completely disconnected from the grid, not for energy savings as much as just, being disconnected. So we used a sheathing or a gypsum sheathing, and then which is a dense element barrier system, which has an integrated water resistive barrier into it. It's like zip for gyp, and they have a liquid flashing that they apply to the seams and all the screw holes, all the screws, just so for continuity. We have a 20 gauge hat channels and then a 20 gauge corrugated metal cladding. So it's zero wood in this entire structure, fire resistant, mold resistant, and nothing for the termites to chew on. Obviously, we had wood trim and cabinetry and those sorts of things inside, but finding their way in there was difficult with an air change or with an airtightness like that. And again, this is the roof, 8 inches on top of, this is a little layer of gypsum sheathing and a corrugated metal deck. Under the slab, we have 4 inches of Rockwool, of stone wool, about 4 feet in, and then 2 inches everywhere else. So the entire slab, the whole structure is wrapped in a stone wool blanket. These are the hygrothermic results for these assemblies. This shows 3 layers of 2 inch, but we ended up with 2 layers of 3 inch. This was our mock-up wall. So you can see the metal framing, gypsum sheathing, and that red goop right there. That's the liquid flashing. So here is our assembly showing the temperature at the sheathing layer. And then if we didn't do that. Here we are, 18 degrees again. This is the project we're about to finish up here in Marietta, Georgia. And this is from one of the articles we did at JLC showing this assembly. You can see the whole slab again wrapped in insulation. We cannot use stone wool underneath the footer here, so we do use either XPS or EPS, and it can be borate treated or we treat it on site. And then we wrap on top of all the insulation here. You can see we go 4 feet in with 4-inch and then 2-inch the rest of the way. But the entire slab turned down is wrapped. And then we continue that insulation up. We did a liquid applied water resistive barrier here. These are our air and vapor control layers over a 1/2-inch sheathing, and then just wood framing, 2x4 wood framing. And so we've got, then on top of the insulation, we have a termite proof vapor barrier called Pango wrap. And so if you seal it perfectly, you are going to, this is, what we like about this is not having to treat with chemicals the soil. So, and then details like this, super important. We've got a little Termaf tape here. We're sealing the gap here first, and then we cover it with a termite proof tape. And then we overlap our air and moisture barrier here over the top of that, and then it overlaps this termite shield here. Also an insulation protector that we put in for construction. So as people go in and out through the exterior wall there, they're not kicking our insulation and destroying it and having to replace it later. So these are some shots of construction, both in Marietta and North Carolina, but this is borate treated here, and this is XPS that we treated on site with just a spray of borate. This is what it looks like going around the corner here from vertical to horizontal. And then we just, and then this is them packing really, really well. Of course, getting our soil perfect was, that's another discussion, but this is everything within 98% compaction rate. Here, just a shot of that turned down slab. This is just working our way up the assembly. So always the insulation 4 inches, type 6 XPS or EPS, which means it has a higher bearing capacity than soil does. And this is all this formwork here that is custom to this, and we have to, of course, to hold the insulation up, we've got these little spacers here. But this is what it looks like, the whole slab insulated. And then this is our vapor barrier. This is the Pango wrap here. This is not the Pango wrap. It's not doesn't have that termite resistance to it. But now this is all of our projects we're using this Pango. And this is the detail through a penetration there. We reinforce our slabs anywhere from 5 to 8 inches. We did all 8-inch slabs up in North Carolina, just because we didn't want any, just thinking durability long term. So we do rebar every 16 inches here in the middle of the slab. And then we protect our slabs with a non-perforated membrane, and this also helps the slab cure longer, which makes it stronger. So we keep this on until we're ready for finishes. And over time, it starts to leak through some of the seams as traffic hits it. But for the first 6 months, 4 to 6 months of the while it's down, it is still holding moisture. Actually, 2 to 4 months, and it's still holding that moisture. And you can see it on the underside of this wrap. This is the 18-gauge metal framing, super durable, lots of 12-inch on center. And because steel and metal is so conductive, we really didn't want to consider cavity. That's why the continuous on the exterior was so important here, and why we did so much there. And then this is that sheeting layer with the integrated WRB, and the red is the liquid flashing. And you can see every screw is covered and every seam and corner filled up with this liquid flashing. It's our mock-up wall. They're just testing things out here. I always tell them, this is the time, excuse me, this is the time to mess up, not when we're actually doing it real. So go ahead and try away here and have fun. So then you see all this is horizontal because we do have the metal cladding, just corrugated 20 gauge, and they're working their way up. And you see fewer and fewer of these washers here because they realized they could just stack it and it held itself up until we got the furring strips on. So we build the walls first, and then we put the roof on. And you see we're staggering both horizontally and vertically. And then once the roof is on, we got our furring strips here, and then we started putting our roofs on. And here you go. This is what it looks like, kind of wrapped up there. So they were able to put all the insulation on before any of the furring strips, which worked out real nice for them. This is the house in Marietta. This is, we do have horizontal here and vertical. This was because of the vertical siding that we had. This is also, like I said, climate zone 3A, got down to 0.05 ACH50. Here's the assembly. We went with two layers of 2 inch on the walls, and then 2 layers of 3.5 inch on the roof. And the reason for the 3.5 inch is we have outriggers that are 2x4 outriggers, so that worked with that dimension. And they're embedded in the insulation, so it was important to keep the assembly simple. And again, the continuity below, and so we go from wall to roof, same assembly. And we used Polywall here, which is their liquid applied membrane. And we test our houses after we get this done. Then we do penetrations. We test it again, and that's for the air leakage. That's what the blower door is there for. And we went from 0.6 or 0.07 ACH50 down to 0.05 ACH50 from this stage to penetration, because we were able to identify during this stage where the leaks were. Then we addressed those, made penetrations, sealed those up, and we're able to get tighter, even tighter. And it's done by, this is our painter. So he was able to do all of this labor because that's their recommended application is with the roller. So it worked out well. These are the outriggers that I mentioned. So these are 2x4s. You have all the 3.5 inch insulation, first layer fits in there. These are framed exactly 2 by 4 foot, which is the size of the insulation panel. And so these are the clips tie into the roof structure. And then we covered, this is on the underside of the back porch. You can see the insulation just continues so that we could keep the thickness and the profile of our roof. And it also helps with when she's out here on her screen porch, it helps with heat gain in that area on the exterior as well. So this is all these overhangs are built on top of the roof. And here's this canopy structure is built to the exterior. There's a bolt here and then screws through here, but none of the steel, this is a little rubber gasket here. None of it's in physical contact with the sheathing. This is our roof. All of these, we did all of the roof furring strips at a 45 degrees to promote drainage. But they're lined up and they're attached through with 9-inch screws into the trusses and roof structure below. And this is a continuous core vent here for the drainage. You see our gap there, that's our rain screen and ventilation cavity. This is the core vent up here, allows the air to flow up and in through the cavity and up to the top side of the roof. Again, mock-up wall on every project, test to allow them to practice and mess up if they need to. This is we have a ventilation strip at the bottom and at the top, and Anyway, so 4 inches here, and then the roof gets another 7 inches. This is what it looks like kind of right before we started cladding it. The canopies, of course, this is south facing, so that's why we have all these canopies, but we also have 4 to 5 inches of protection here because we installed the windows at the sheeting layer. We didn't build it out to be flush. This is called an INI window, so it helps with protection against the elements, but this also helps with that and the shading. So everywhere else that we have horizontal here, we have horizontal or vertical strips. We do horizontal siding. On the corners, we're using a metal. We're using fry reglet as metal trim instead of cementitious trim, and so we needed to have something horizontal here because insulation is here and the structure is back over here. So we had to cantilever this out, tie this into the structure so that it could cantilever out, and then we have something to attach to right at the corner. Just another shot here of, and you can see there are none of the washers on this job. We didn't use anything because we had our first layer down here and we just stacked on top of it, and we got up to a certain level and they started installing these furring strips, and that ended up being what held the insulation from toppling over until they were able to secure those furring strips. This is one that's been designed very similar to the off-grid home, except all wood construction. So the assembly is exactly the same, except we're using wood. So 6 inches on the walls, 8 inches on the roof. And so that's, there we are. That's just a few of the projects we've got going on. And so I'm going to hand it over to Dan Edelman here now for him to say a few words, and then we'll come back to me for a minute, and then we'll get to some questions. So Dan, take it away.
Thanks for watching this video. For your convenience, we've loaded up the next video as part of this series. If you enjoyed this video, give Chris and Dan a thumbs up.